Okay, once again, we're still talking about our friend, the egotistical parabola, also known as a quadratic. And we're back to looking at ways to find the roots of the parabola. So if you remember, roots are, we have a graph, and then we have a parabola. And we want to know where the parabola crosses the x-axis. You've been doing this since you were in the 8th grade. That's what factoring. That was the first way you learned how to find the roots. You factored. Yesterday, you learned the second way. You could use the quadratic formula. The quadratic formula always works. Factoring, as much as you hate it, is a shortcut. And there's a third way. It's actually quicker than the quadratic formula, but you have to be very good at basic math skills, like taking half of numbers. And that's what you're learning today. It's called completing the square. Okay, so you'll be asked on the regions to find the roots of this polynomial. And for the most part, the first thing everybody's going to try and do is factor it. So give me numbers that multiply to 2, but add up to 4. And that's not happening. And of course they're going to give you that one on the regions, because they don't want you to factor. Factor is something you do when you're a freshman. So the next level of child is going to go for the good old quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. For the 10 people who have watched the video, because I'm making this at 10 o'clock at night, the night you should have watched it, and there's only 10 of you. No, you failed that quiz I gave you today. Okay, so I take the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Clean it up. Negative 4 plus or minus the square root of 16 plus 8. That's negative 4 plus or minus the square root of 24, which breaks down to negative 4 plus or minus 24 breaks down to the square root of 4, square root of 6. That gets me negative 4 plus or minus 2 radical 6 all over 2. And that gets me to my final answer, which is negative 2 plus or minus the square root of 6. There, I want to highlight that so it sticks out. Okay, that's quadratic formula. Look at all that work. Well, completing the square has a series of steps. And I know that right now you're looking at these going, oh my gosh, that's so much. But if you follow this template and you take the time to write this down in your notes right now, it's really simple. So we're going to do the same equation we just did on the other page, and we're going to complete the square. All right, so the first step, in order to do completing the square, the leading coefficient must be 1. The leading coefficient is what's in front of the x squared. So let's look. Is that leading coefficient 1? Yes. Excellent. Step 2. Get the x's alone on one side of the equation. Well, this is an x. This is an x. But this 2 is not. So it's going to get kicked to the other side of the equation. Now, here comes the completing the square part. Take half the b value. Okay, the b value is 4, so I'm going to take half of that. Square this number. All right, so that turns into 2 squared. And balance the equation by adding it to both sides. So that means I have my x squared plus 4x. I'm going to add the 4 onto this side. And I'm going to add the 4 onto the other side. There, I balanced it by giving it the same to both sides. Okay, I'm going to clean that up now. So I get x squared plus 4x plus 4 equals 6. Now, if you don't realize it, that's where you completed the square. You made this. Let me get, let's get that right there. You made this into a perfect squared binomial. In other words, if I factor the left side, that comes out to be x plus 2 times x plus 2, and I can rewrite that as a perfect square. And if you're one of the bright ones, you're kind of going, oh, I get it. Because remember the shortcut to squaring a binomial? Square the first, square the last, double to get the middle. That's why when we were up here, we took half. Okay. Now we're going to solve for x. We want to get x alone. That means we have x plus 2 quantity squared equals 6. To undo a square, I square root, so I'm going to square root both sides. And I get x plus 2 equals plus or minus the square root of 6. Because when you take the square root of something, it could be plus or minus. And then when I move the 2 over to the other side, look, I get the same answer down here as I got when I did the quadratic equation. Now it's new to you, and you may think this is really long, but really all you have to do is get the x's alone, take half and add, factor, solve. And if you didn't even notice that, see this number right here? That's always the number that ends up going when you complete the square. Okay, last example. Find the roots of the polynomial. As soon as it says find the roots of the polynomial, I have my 3 choices: factor, quadratic, or complete the square. On the Regents, they're going to actually ask you to complete the square. You can't just sit here and go, oh, I'll just do the quadratic. No, because then you won't get any credit. Okay, in order to do completing the square, the leading coefficient must be 1. Oh, crap. My leading coefficient here is 1/4. So how am I going to get rid of that? I'm going to take this entire equation and multiply it by 4. Okay, 4 times 1/4 gets me 1x squared. 4 times 3/4 gets me 3x. 4 times negative 3/2 gets me minus 6. And 4 times 0 gets me 0. Okay, get the x's alone. All right, so x squared can stay, positive 3x can stay, and the 6 gets kicked to the other side because it's not 3. So half of 3 is 1.5. Square this number. So 1.5 squared is 2.25. balance the equation by adding it to both sides. X squared plus 3x is one side, and I'm going to add, and I don't like decimals. 2.25, that's 2 1/4, so I'm going to write that as 9/4 equals 6, and then I got to add 9/4 to the other side because I got to keep it balanced. All right, so if I clean that all up, I get x squared plus 3x plus 9/4 equals, well, 6 is really 24/4 when I get a common denominator, so that's 33/4. Rewrite the left side as a binomial squared. All right, so that means I gotta factor this. Oh, but I remember my shortcut from the other's page. This ends up showing up in my binomial. So if I factored this, this would really be x and x. Two numbers that multiply to 9/4 are, 3/2. And do 3/2 plus 3/2 get me 3? Yep, 3/2 plus 3/2. 1/2, 1 1/2 plus 1 1/2 is 3. Okay, so I can rewrite this as a binomial squared. That's x plus 3/2 squared. And now I can solve for x by taking the square root. So that's x plus 3/2 equals, remember when you take the square root, it's plus or minus. I have to take the square root of 33 and 4. Well, I can't take the square root of 33. I can take the square root of 4. I like this. I got common denominators now. Now when I get the x alone, all I have to do is move the negative 3/2 to the other side. And voila. There is my answer.